So, good morning everyone. I am Adrian Clive in Napoles and I'm going to discuss all about the Great Circle Ceiling. So first we're going to do is that we are going to put or to write the positions A and B. So position A is position A is 48 degrees and 30 minutes north, and its longitude is 5 degrees and 10 minutes west, while in position B is 22 degrees south and its longitude is 40 degrees and 40 minutes west. So after that we are going to do the triangle. So first, let's write the position A here, which is in the north hemisphere. A is equal to 48 degrees and 30 minutes north and 5 degrees and 10 minutes west. So after that, we are going to write the position B where it's located in the southern hemisphere. So here, we are going to write this. So here. So the position B is equal to 22 degrees south and 40 degrees and 40 minutes west, and its south pole is here. So where we are going to locate this, so here, which is the going to the D long or the P. So in order for us to solve it, the D long, the formula of the D long is that D long is equal to D long is equal to longitude B minus longitude A. So the question is why is there why are we going to use the negative sign or the minus sign? Because the rule says if the same name or the same location where here is that if it is the same, we're going to subtract it, while if it is in different name, we're going to add it. So since the longitude of the both of them is west, so we're going to subtract it. So substitute longitude B is equal to 40 degrees and 40 minutes west minus longitude A is equal to 5 degrees and 10 minutes west. So in order for us to to get the D long is that we will going to subtract the 40 degrees and 40 minutes minus 5 degrees and 10 minutes is equal to 35 degrees and 30 minutes, and that is our D long. So the next step is that we are going to get the distance. So the distance, the formula of the distance is this: the cosine GCD is equal to cosine D long times cosine latitude A or latitude 1 times cosine latitude 2 plus or minus the sine latitude A or latitude 1 times sine latitude 2. So let's substitute since the cosine, the d long is 35 degrees and 30 minutes. So here it is. So it we will going to multiply it by cosine the latitude 1. Here it is the latitude 1, the 48 degrees and 30 minutes. Here it goes. Then we will multiply it also by the latitude 2, which is the 22 degrees, and then we will I'm using the subtraction because the rule says if it is crossing the situation, you will use the subtraction, while if it not crossing the equator, we will going to use the addition. So since it is crossing, we will use it subtraction, and then after that we will going to multiply it subtract it by sine latitude 1, which is 48 sine latitude 1, which is 48 degrees and 30 minutes, times the sine latitude 2, which is the 22 degrees. So let's get cosine the 35 degrees and 30 minutes times the cosine latitude 1, which is 48 degrees and 30 minutes also, and then times the latitude 2, the cosine latitude 2, which is 22 degrees, then equals, and then we will going to subtract it by sine 48 degrees and 30 minutes times sine 22 degrees is equal to, there you go, the 0.2196. Then after getting that, we will going to inverse it to cosine. So cosine inverse cosine is equal to 0 times 0.296. So here we are going to inverse it to cosine. Inverse shift cosine is equal to 77. We will convert it to degree. 77 degrees and 18.5. So we'll write it as 77 degrees and 18.5 minutes. And then after that, we will going to multiply it by 60 times 60 times 60 is equal to the 4,638.9 is equal to 4,638.9. So it is miles because it is distance. There you go. We already get the distance. So now we are here to get our initial course. So the formula of the initial course is the initial course. The formula of the initial course is that sine initial course is equal to cosine latitude B times sine d long all over sine distance. So here, let's allocate our latitude B. So cosine latitude B is 22 degrees. So we'll write this 22 degrees times the sine, the long is there, the 35 degrees and 30 minutes. 35 degrees and 30 minutes all over sine the distance is 77 77 degrees 18.5 minutes. So let's calculate. So first, let's do the cosine 22 degrees times sine 35 degrees and 30 minutes over sine 77 degrees and 18.5 minutes is equal to, there you get the answer, the 0.5519. So after that we will inverse it to sine. So the answer is there, the 33.4, then we will convert it to degree, then 33 degrees and 29.5 minutes. So let's write it down here, 33 degrees and 5 southwest, because, and after that we will subtract it by 270 degrees. So why 270? Because it is in the southwest, and it is the number of degree in the quadrant 3 is 270. So we'll subtract it by 270 minus 270 degrees is equal to, there you go, 200. And then after that we will convert it to degree, 236 degree and 30.8. So we will write it down here. So through that we will now having our we will now have our the through 236 degrees and 30 point is my answer for the initial course, 236 degrees 30.8 minutes through. After getting the initial course, we will also get the final course. So the formula of the final course is, it's right here first, final course sine final course is equal to cosine latitude 1 times sine d long all over sine distance. Next we will substitute. So cosine latitude 1 is 48 degrees and 30 minutes times sine the d long is 35 degrees and 30 minutes. So all over sine the distance is there, the distance is 77 degrees and 18.5 minutes, 77 degrees 18.5 minutes. So after that we will solve that. So first, cosine 48 degrees and 30 minutes times sine 35 degrees and 30 minutes all over sine 77 degrees and 18.5 degrees a minute, so equal. So after getting that, we will shift tangent, shift sine, inverse sine is equal to, convert it to degree. Here you go. The answer is 23 degrees and 11.5 minutes. So it is northeast, because northeast is that's why northeast it is, because 23 degrees is located in the first quadrant in the upper right area, so that's why the northeast, we will subtract it by 0. So since the degree there is 0, so we will subtract it by 0. So the answer is, for to get the true, so the answer is 23 degrees and 11.5 minutes true. That is our final course. So after solving the final course, we'll move on to solve the latitude vertex. So latitude vertex. So first, we will write the latitude vertex. So latitude vertex. So latitude vertex is equal to cosine latitude vertex is equal to cosine latitude 1 times sine initial course. So let's substitute. Yes, cosine latitude 1 is 48 degrees and 30 minutes. 30 degrees and 30 minutes times sine initial course. Our initial course is there, 33 degrees and 29.5 minutes. I'll write it, 33 degrees 29.5 minutes. So after that, we will solve it. Here, cosine 48 degrees and 30 minutes times sine 33 degrees 29.5 minutes is equal to, the answer is 0 there. The answer is, then we will inverse it to cosine to 0.3656. So inverse it to cosine. The answer is, and then after that we will convert it into degrees. The answer is 68 degrees and 33.9 minutes. 68 degrees and 33.9 minutes. So that is our latitude vertex. So after getting the latitude vertex, we'll move on to longitude vertex. So in order for us to get the longitude vertex, first we will get the long vertex. So first, here, the longitude vertex. So the d-long, the formula of d-long is sine d-long vertex is equal to cosine initial course all over sine latitude vertex. So substitute. So cosine, what is the value of the initial course? So the value of the initial course is here, there, 33 degrees and 29.5 minutes. So let's write it here, 33 degrees 29.5 minutes over the sine latitude vertex is there. No, wrong. Here that we solved a while ago, that is 68 degrees 33.9 minutes. So let's solve. So cosine 33 degrees 29.5 minutes over sine 68 degrees and 33.9 minutes is equal to 8, 9. So after getting the answer here, we will inverse it to sine 0.895935. Sa inverse sine, the answer is 63, and then convert it into degree. The answer is 63 degrees and 37.4 minutes. So the answer is 63 degrees and 37.4 minutes. So that is our D long. So, and after that, we already have, it is west. So after getting the D long vertex, let's move on to get the longitude vertex. So the formula of the getting the longitude vertex is the D long vertex plus or minus the longitude longitude A or longitude 1. So longitude A, long A is equal to 05 degrees and 10 minutes west. So after that, plus or minus, so since they have the same position or hemisphere, oh yes, we will going to add it. So add it, so we will add it 63 degrees and 37. We'll use the plus sign to get the longitude vertex. So let's solve the 63 degrees 37.4 minutes plus longitude A is 05 degrees and 10 minutes is equal to 68 degrees and 47 minutes. So longitude vertex is 68 degrees and 47 minutes west. So that is our longitude vertex. So that's all, and thank you for listening and watching my video presentation. God bless everyone.